Oumuamua, the mysterious interstellar object whose peculiar orbits captured the attention of observers in late 2017, is making headlines once more. This time, scientists are afraid. Oumuamua is scheduled to make a direct collision with Earth in only 2 weeks, an unprecedented occurrence. This cosmic event is especially disturbing because, in addition to the imminent collision, Oumuamua appears to be traveling at an alarming speed. Are we on the verge of a catastrophe? Come explore the serious warning that scientists have issued regarding Oumuamua's direct effect on our world. Upon hearing the words alien probes, what first springs to mind? Maybe it brings to mind classic science fiction films with aliens examining people with weird devices. Alternatively, perhaps you see Oumuamua, the enigmatic cigar-shaped object that streaked by our solar system a few years ago. In 2017, researchers like Harvard University's Avi Loeb began discussing the potential of actual space probes launched by far-off civilizations. As opposed to the fictitious sort, these spacecrafts would resemble the ones that humans have launched into orbit, such as Voyager and New Horizons. The crucial query is Oumuamua a comparable probe, albeit one that hails from a different planet? Plasma physicist Avi Loeb has even hypothesized that Oumuamua itself may have been an extraterrestrial spaceship. Although that theory may seem improbable, scientists are really excited about it. But there are significant obstacles. To begin with, the distances in space are astounding. A probe sent by extraterrestrials from the Andromeda Galaxy would have to traverse an astounding 2.5 million light-years, or 6 trillion miles, to reach Earth. Then there is the issue of time. How will they ensure that their probe arrives here prior to the fall of their civilization? However, assuming they resolve those issues, even so, they would still need to construct a probe robust enough to endure all of the hostile environments found in space, including radiation and space debris. Imagine constructing something incredibly robust and resilient, perhaps made of a substance that is as hard as a diamond but can withstand impact without shattering. Scientists were ecstatic when Oumuamua arrived in 2017. Despite the difficulties, they had been hoping for an interstellar visitor just like it for decades. Who knows? We could find out eventually that we're not the only ones in the cosmos. An exciting finding was made back in 2017 by NASA's Science Associate Administrator, Thomas Sabuchin. The confirmation of interstellar objects like Oumuamua captured the interest of astronomers all across the world. Then, in August 2019, a mere 2 years later, 2I/Borisov, another interstellar object, was discovered. Borisov, in contrast to Oumuamua, possessed the characteristic comet traits, such as a prominent tail and coma. This enigmatic guest provided astronomers with a unique view into extraterrestrial planetary systems. When first observed, Oumuamua seemed like a massive cylinder that was 10 times longer than it was broad. However, further observations showed that its shape was more like a pancake. Occurrences of comparable forms in other Kuiper Belt objects point to a shared formation process. Astronomers were able to determine Oumuamua's size and form by observing its brightness as it traveled through space. It's interesting to note that Oumuamua's trip can be linked to 4 probable near encounters, the closest of which was with the red dwarf star HIP 3757. After this discovery, scientists began to question where Oumuamua came from and if it had been floating through space for millions of years with an unknown origin. Stellar bodies such as comets, asteroids, and planets circle the Sun in close orbits, like a busy neighborhood. However, something remarkable occurred in 2017. Oumuamua, a strange visitor, arrived in our cosmic neighborhood. Its course was not a tidy circle like the others. Rather, it was hyperbolic, speeding past the Sun at such a high rate that it was little impacted by its gravity. It resembled a cosmic projectile speeding across space. On October 19, 2017, University of Hawaii astronomer Rob Warwick made the first observation of Oumuamua. It was already 21 million miles from Earth at that point and traveled as near as 15 million miles before departing from our solar system with a push from the Sun's gravity. This intergalactic visitor was traveling at an astounding 54.2 kilometers per second. However, it was not an easy endeavor to get a peek at Oumuamua. It was little and swift, allowing us only a few weeks to do in-depth research on it. Fortunately, several amazing photos were taken by the Hubble Space Telescope and other strong observatories, showing Oumuamua as a tiny object in the vast expanse of space. Oumuamua accelerated outward toward the constellation Pegasus and then vanished from our line of sight, disappearing into the frigid Kuiper Belt, the region beyond Neptune. But would it come back? And just who or what was Oumuamua? Some believe it is simply a dead comet that has been stripped of its gases over billions of years, while others believe it to be an extraterrestrial probe. There's no denying that Oumuamua's brief visit has captured the attention of scientists and space enthusiasts alike, igniting discussions and piquing our interest in the secrets of space. Oumuamua's voyage was not without its mysteries, though. When the Hubble Space Telescope observed it after passing the Sun, it detected an odd acceleration that was not caused by gravity. Typically, comets release dust and water vapor, creating a tail that propels them forward. However, Oumuamua showed no indications of leaking water or other volatile materials commonly observed in comets. What then could Oumuamua be? Unlocking its secrets remains an ongoing challenge. One theory suggests it is a piece of nitrogen ice. Researchers Alan Jackson and Stephen Desch of Arizona State University speculate that Oumuamua might be a fragment blasted off a Pluto-like planet by a powerful impact. The additional boost could have been present if the nitrogen ice melted due to the sun's heat. However, for Oumuamua to appear as pale as it did, it would have to be smaller than initially believed. Another theory posits that cosmic rays reacting with surface ice in interstellar space released hydrogen gas trapped in amorphous water ice, propelling it forward. This proposal, put forth by Jennifer Bergner of Berkeley University and Daryl Seligman of Cornell University, contends that as the sun warmed Oumuamua, hydrogen escaped, altering the ice's crystalline structure. Furthermore, two intriguing theories from Harvard University astronomers Avi Loeb and Shmuel Bialy propose that Oumuamua may be a solar-powered spaceship. They suggested the possibility of alien technology at work, explaining the many anomalies noted in this interstellar visitor. Oumuamua's trajectory indicates it came from beyond our solar system, but since we were unable to get a close-up of this visitor, its actual dimensions remain unknown. To estimate its size, astronomers relied on its brightness and their understanding of how comets and asteroids reflect light. The comet idea is questioned by several scientists since Oumuamua has not been detected to have a coma or tail. Its rotation period would also be altered by gaining a comet's characteristic features, which hasn't been observed. The non-gravitational acceleration refutes the theory that Oumuamua's apparent movement originated from a force that separated it from its parent object. Alternatively, there's the intriguing hypothesis about sunlight. If Oumuamua is very thin, between 0.3 and 0.9 millimeters thick, solar radiation pressure may be the cause of its reported movement. Scientists hypothesize that Oumuamua may be a light sail, a technique proven in space missions such as NASA's NanoSail, D2 and the Japanese Icaros probe. These light sails travel across space by harnessing the kinetic energy of photons. According to estimates, Oumuamua might travel through interstellar space on a light sail for a considerable amount of time. Its estimated distance from its parent system, wherever it may be, is at least 16,000 light-years. The possibility that Oumuamua is space junk or an extraterrestrial ship is taken seriously. It may have come to Earth by mistake or could be a deliberately launched spaceship studying our solar system. The peculiar discovery method of Oumuamua lends credence to these theories. Finding it as we did suggests that every star in the Milky Way ejects a huge number of such objects over its lifespan. If it is a member of a random population of objects, this implies there are as many such objects as Oumuamua in our solar system. Pinpointing Oumuamua's origin is difficult due to its motions near alignment with the local standard of rest, a region of the Milky Way galaxy. Oumuamua is traveling towards the outer solar system and will move too fast for conventional rockets to catch up with. Although initiatives like Breakthrough Starshot aim to send small robotic probes with sails hurtling towards it at great speeds, this may not be possible in the near future. Whether or not we reach Oumuamua, learning from its visit can help prepare us for further interactions. Astronomers can study other fascinating objects now in view more effectively by making detailed observations and using knowledge gained from this experience. More thought and planning would be necessary if the Oumuamua space probe were to return. If we contemplate the possibility of something remarkable occurring, might we think about constructing a shipyard here in certain territories? In the event of a returning asteroid space probe, humans would need a better understanding of dark energy in the universe to build spacecraft capable of pursuing it. Sending a vessel after the asteroid probe is one idea, but it will be extremely difficult. Oumuamua will pass beyond Saturn's orbit in 2 years due to its hyperbolic excess velocity of approximately $5 per year. This is the fastest object humans have ever encountered in space. What sort of vessel would we require? Should we utilize solar sails or something more exotic like a wormhole for propulsion? Wormholes are a fascinating idea, but there are significant challenges, such as collapse, connections to other worlds, and uncertainty about their construction. Cosmic gateways and interstellar travel have been hypothesized since 1935 when Nathan Rosen and Albert Einstein introduced the concept of wormholes in the context of general relativity. Einstein-Rosen bridges, or wormholes, are theoretical passageways connecting various locations in spacetime. These wormholes could provide shortcuts, reducing the time and distance required to traverse the cosmos. Despite their theoretical basis in Einstein's equations, wormholes have neither been observed nor verified. The existence of wormholes remains speculative, as it is difficult to confirm their connection to black holes or to determine if objects or people entering black holes could survive. Einstein's theory of spacetime forms the foundation of this idea, positing spacetime as a fabric warped by the interplay of mass and energy. This warping results in gravitational effects that influence the motion of planets and stars. Wormholes, if they exist, would further alter spacetime, creating potential shortcuts. Einstein and other scientists have proposed various forms of wormholes, including traversable wormholes, which are popular in science fiction for their ability to connect different regions of the cosmos. Non-traversable wormholes, on the other hand, may lack escape routes or collapse before anything can pass through. Theoretical wormholes also include inter-universe wormholes, which might link our universe to parallel ones. However, the scientific community still lacks concrete evidence for these phenomena. Wormholes are mathematically supported by Einstein's general relativity, but they remain open to interpretation and require further research. The pursuit of understanding wormholes is ongoing. While theories abound, practical exploration of these cosmic shortcuts remains elusive. Perhaps, under ideal conditions, we will one day solve the mysteries of wormholes. Until then, their enigmatic nature continues to inspire scientific curiosity, creative imagination, and the possibility of uncovering new facets of our vast universe.